So welcome, family and friends of Kaan. He is going to be talking about work he did as part of his Master's of Engineering. So this is a little different than sort of an MS. So I have good news and good news. Let me start with the good news. He's already passed. So the stress is off. So that's good. The second good news is if you like seafloor acoustics, this is cool stuff. You all like seafloor. Really, there's some interesting stuff. Jen and I have been doing this type of work for a few years now, and we've seen hints of what some of the cool stuff Kaan's going to show, but he caught some big signals, and so it's extremely interesting. And Kaan is going to write a journal article based on this, right?
Yes.
Okay.
I am. It's happening.
The last thing I wanted to say, I was talking to Jen, and I'm like, I need to have a funny story about Kaan, because that's what we do, right? And I don't really have one, except to say that he went out to the field a lot. He took a lot of data, and he did go with us to help us with other projects, but just for his work, he went out multiple times. And I would say 99% of the time, he was by himself, so because we're busy. So I would be at my desk, and he would start sending emails with images from his echo sounders that he's using. And when I get those images and they look like this, if you've been on a boat and seen an echo sounder where the trace looks like that, you don't want to be on that boat. You know the one I'm talking about.
I do.
Why does the echo sound, he said, why does that look like that? I said, what do the seas look like? Anyway, thank you, Kaan. Take it away.
Thank you. Thank you, Tony. Hello, everyone. My name's Kaan Cav. I'm a Master's of Engineering student, as Tony had mentioned, with a degree in ocean engineering and ocean mapping. I'm going to be talking about the temporal variability of seafloor acoustic scattering, or as I like to refer to it, echoes through time. So before I jump into the science, I'd like to do a land acknowledgement. So hello again, or Kwekwe, as the indigenous people of these lands, the Abenakis, would have said. You can see here in this region, we're located around this area, so firmly in Abenaki territory. This whole region is referred to as Wabanaki, the Dawnland. And then here on the left, I've got an image, an illustration of an Abenaki tribe doing things like constructing a birch bark canoe on the water there in the distance. So truly these people were the first scientists of this land. And the region we occupy is referred to as Endokina, so modern day Vermont and New Hampshire. So moving into my research, I'd like to talk a little bit about the dynamic nature of the seafloor to begin with. On this graphic on the right, I've got the cycle of seasons throughout the year. Starting in summer, we see a lot of biology, lobsters, sand dollars, seaweed, and it's pretty calm, so not a lot of storm activity. Progressing into the fall, we see those storms beginning to pick up, altering the seafloor interface, as well as affecting the amount of biology that's in the region. So biology is beginning to move away. Then, in the winter, that trend continues. Storms are getting bigger. Biology is continuing to decrease. And then into the spring, storms are dying down. Biology is beginning to re-inhabit that area. So clearly, the seafloor is not static, and these changes are occurring on multiple time scales, on the order of hours sometimes when we're talking about storms, and then also those seasonal changes with the biological activity. So a real life example of those seafloor changes, we can see an image taken on August 16th, and then 5 days later, another image of the same seafloor, and it's changed quite a bit. We see this is quite flat, and some bed forms have formed over there. So why does that matter? Sonar-based seafloor classification is making the assumption that the acoustic signature of the seafloor is relatively stable. However, the temporal changes in those seafloor properties are going to affect the acoustic response, which could lead to things like misinterpretation. So accounting for that variability is really critical to get accurate, up-to-date mapping. The knowledge gaps that we're facing in the field right now are things like spatial, temporal variability, and environmental drivers there on the bottom of the iceberg. And then the tip of the iceberg is some of the things we understand a bit better. This research is focusing on that spatial and more so temporal variability. And we currently, the models which are used make the assumption that those seafloor properties are static. So the goal is to understand how those seafloor variabilities are affecting the seafloor scattering strength. So the objectives of this research are to measure the scattering strength of a sandy seafloor patch over multiple months, compare those scattering strengths from a mobile platform as well as a stationary platform on various timescales, and then quantify the temporal changes of the sandy sedimented region that we're researching, which can be seen here. So we're located about an hour north of Boston at the University of New Hampshire. The study site is at the mouth of the Piscataqua River, shown by this red dot. And we've got another map here on the right. So the vessel track that mobile platform I was referring to is shown by that red line, and then the tripod's location is shown by the red triangle. What I want you guys to take away from this is that it's a sandy sedimented region. So the equipment that I used, I had a 70 kilohertz, 120 kilohertz, 200 and 333 kilohertz split beam transducers on board the RVGS. These were attached to a piece of hardware I refer to as the angle mount, which allowed me to collect acoustic measurements spanning from a 90-degree grazing angle out to 20 degrees in 5-degree increments. These were driven by a wideband transceiver tube. I got motion corrections from our inertial navigation system, and then we took CTD casts at the beginning and end of every survey. And these were taken during the first two deployments of the tripod, so spanning the fall and winter of those years, and spring. The scattering strength computations for the vessel data were a bit simpler in that I could average, since scattering strength is a statistical quantity, I was averaging in time. So what we're seeing here is the vessel track in that black solid line, and then those dots that we're seeing are the positions of the pings along the seafloor for a few different grazing angles. That black rectangle is zoomed into on the right plot, and that's the region I'm averaging over, shown by the blue line. So it's spanning about 130 meters, and then the distance from the tripod to the area that we're collecting acoustic measurements with the vessel from. So the stationary platform. This had a 70 kilohertz split beam, a 200 kilohertz and 333 kilohertz single beam on board, and these were driven by a WBAT. We would ping 50 times every hour on the hour. We had a CTD on board to collect those environmental measurements, such as significant wave height. And then I also had a camera to give some optical situational awareness. And these, I had 3 tripod deployments spanning 2022 to 2025, and they would normally last 5 to 7 months. So here's my workflow. I mobilized and I acquired the data on board the vessel. I had redesigned and constructed the tripod, and then I would go through the deployment and recovery procedures for that. I would parse out all the acoustic data. I would apply motion corrections where needed for the vessel data. And I would account for things like the tripod shifting during its long deployments. I generated a phase difference-based wave height model to account for the malfunction of a CTD during the second deployment. And then I applied my acoustic corrections, and I did some seafloor topography corrections to account for true grazing angle from the tripod. And that's how I got to the scattering strength and angular response values, which I'll show in a bit. So, the unaveraged interface scattering strength. As I mentioned, scattering strength is a statistical quantity. So, normally on the vessel, you'll average a long track in an area where you know you have the same sediment, similar sediment. Whereas with the tripod, we didn't have the luxury of a moving platform recording those measurements. So instead, we're doing something where we're averaging spatially. First, we would solve for SB, which is the received level subtracted, the received level with the source level subtracted from it. And then we would account for the two-way beam pattern, transmission losses, so spherical spreading and attenuation. And then we would account for the insonified area, which is defined on the edges by the 3 dB down limits. And then in the X direction, it's defined by the pulse length, which would end up being, as you see there in the blue, portion of an arc. So this is what that looks like, that unaveraged interface scattering strength. So what we're seeing right now is time on the horizontal axis, and then on the left side of the vertical axis, we've got that X distance from the tripod, and then on the right side of the horizontal axis, we've got, of the vertical axis, we've got approximate grazing angles with a flat seafloor assumption. And then on the bottom, we have significant wave height, again as a function of time, to give some awareness as to what type of environmentals are occurring during that period. The color bar denotes the strength of the return in dB. What I'd like to point out here is that throughout the deployment, we're seeing changes throughout. There are periods where we have stronger returns, and then a few months later, those returns have subsided in that region. Here we've got bands of strong returns, which are quite interesting. Looks like it could be potentially bed forms that we're facing into. And I'd like to add as well, these white lines are periods that I've removed due to the acoustic response of the seafloor being masked by things like turbidity. So, as I mentioned in the previous slide, there's those potential of bed forms. So those had to be accounted for to get accurate representations of scattering strength at the true grazing angle. This is just an example of how the grazing angle can change as a result of the seafloor topography. I solved for the seafloor topography by using the physical echo arrival angles from that 70 kilohertz split beam transducer I'd mentioned. So what we're seeing here now is, again, time on the horizontal axis. We have that X range from the tripod on the vertical axis, and this image is essentially like we're looking down at the seafloor from above. And then on the color bar, we've got hot denoting, or we have elevation, and so those warmer colors denote higher elevation and the cooler colors denote lower elevation. So I'd like to draw your attention again to this region, which is looks like those bed forms that have stacked up following 3 successive pretty large storms. So from that, once I got the true grazing angle and that unaveraged interface scattering strength, what I would do would be to choose a grazing angle, and then I would average 25 samples closest to that grazing angle of choice. So in this case, 10 degrees, and that would give me an 85% confidence interval with a plus or minus 1.25 dB range. So the gray shading, which is a little hard to see around the dots, is that plus or minus 1.25 dB. And then the blue dots are those hourly measurements of scattering strength. What I'd like to draw people's attention to here is that On daily and weekly scales, we're seeing a good deal of variability, up to 3 dB from day to day and week to week. Following storm events, sometimes we have drops in scattering strengths at multiple different grazing angles, and then following other storm events, one grazing angle will drop in scattering strength and another will not. So really, the processes are occurring differently across various grazing angles. And then here I've just put a 3rd degree fit on top to draw your attention to the fact that from December to April, it drops off a little bit, but it's not super substantial. We're seeing a low in mid-February. However, if we go back in time to August, so this is the 3rd deployment now, where we started in August, we're seeing a much clearer trend, which is pretty cool to see, because we're starting in late summer, up around -30 dB at 10 degrees grazing angle, and then throughout that fall and winter period, we're seeing a lot of storms, and also a subsequent dropping of scattering strength across both those grazing angles that I'm showing you. Then from this, what I'm going to do is I define these periods marked by the gray boxes as Kaan periods, and I will take the average of all of these scattering strength values to present the angular response measurements, which are here. So these are all 3 years angular response curves. We've got grazing angle on the horizontal axis, and then we've got scattering strength on the vertical axis. The color bar is showing us time, so light to dark is early to late season, or later in the field deployment. What we're seeing is there's about 5 dB of variability throughout the season for those first 2 deployments, which started again a bit later in the season, so more into the fall and winter. However, this deployment, this last deployment that starts in August, we're seeing a really clear trend of, as we progress further into the fall and the winter, a substantial drop of about 10 to 12 dB throughout the season. So, I'm showing you guys some scattering strength predictions for a few different sands, so that we'll be able to compare what the models predict to the data I've collected. I'm using some standard input parameters defined by Dr. Daryl Jackson for these 3 different sediments. What I'd like to draw your attention to here is that across the different sediment types, the general trend of scattering strength as grazing angle increases is similar. And as we progress beyond this point, which is the critical angle, the volume scattering contribution begins to increase. And those parameters on the right, the first 5, describe how the acoustics interact with the sediment-water interface, and the sediment and the water generally. And then we've got those roughness parameters, which describe the roughness of the sediment-water interface itself. So those are really of interest. And then we've got some volume parameters as well. So now I've plotted up the model on top of the results that I just showed you, with some input parameters from sediment samples that I took. And I modified these parameters, the roughness and the volume parameters, to give myself a best fit through the data. What we're seeing is that with a reasonable set of parameter choices, the model seems to be lining up with the trend of the data pretty well across all 3 years. So now here are the results from both the tripod, the stationary, and the vessel, the mobile platform. The tripod results are in this region, and then the vessel results are there. Again, what we're seeing here is the trend is it's lining up pretty nicely. We have a pretty nice overlap region between the tripod and the vessel results, and it seems like there's good agreement there. So that's pretty good. Now looking at that with the model plotted on top with those same input parameters that I had mentioned earlier, we're seeing the model is in pretty good agreement with the data that's been collected. And we're also seeing that there is pretty much variability across all grazing angles. It's not like there's a specific grazing angle that's experiencing less variability throughout those deployments and collections. So here, again, is a time series of scattering strength at 20 degrees. I've also plotted the vessel measurements as the red dots throughout the deployment. Our tripod's battery dies, so we lose those measurements around early April. The vessel appears to line up pretty well with the scattering strength measurements recorded from the tripod. What I'd like to note here is that as we're moving further into the spring, our scattering strength values are increasing. So it does seem like there is that trend of that decrease during the winter and then an increase moving back into the spring. So some conjecture about why I think the acoustic response of the seafloor is varying throughout. I'm showing this image again to emphasize that hydrodynamic activity that's occurring quite frequently during the fall and winter seasons is having a significant impact on the scattering strength. As we've seen, there's a lot of variability. On the other side of the coin, we've got biological activity. So here on September 4, we see a little lobster friend who has meandered into the acoustic footprint of the tripod. And then the next day, they've built themselves a little burrow, doing their thing. And then the following day, they've disappeared. So there's things constantly occurring down there. The biology is doing lots of things, and those are definitely going to be affecting the acoustics that are interacting with that seafloor interface. So what I found is that storm-related variability of up to 8 dB was observed. We saw that decrease spanning from summer into the winter of 10 to 12 dB. And the vessel and tripod scattering strength measurements were quite comparable in that overlap region that I showed you guys. The implications of the research that I conducted are that it will provide some sort of baseline understanding of the temporal variability of scattering strength in sandy sediments. It could improve confidence for seafloor classification and habitat mapping, also supporting those acoustic models to better understand what is driving these changes in the temporal variability. And I think most importantly, informing the survey planning to understand periods of stability versus instability. The limitations are that it was site-specific. We're looking at a really tiny patch of seafloor with that tripod. And so it's hard to say if that data will generalize to other sandy sediments. We're only looking at the seasonal scale variability, so we don't know if we're seeing any interannual variability. We had a little bit in there with 3 years, but it's still quite limited. And then it's just a super complex environment. as you guys all know, it is really hard to tease apart the drivers of that change. So I think going forward, what would make sense would be to broaden the spatial coverage to see if these results would be matched in other places. Do longer deployments, more data, that's always a good thing. The model development, seeing if there's a way to predict how those hydrodynamic and biological effects are altering the seafloor water interface. And then I collected a ton of data, as you guys saw. I have data for many frequencies. I just presented the 70 kilohertz today, so I think there's a lot of opportunity to eke out some more information from doing a multi-frequency analysis of the other data that I collected. And then I think some type of technology integration would be cool. Like doing a glider, for example, to collect measurements that would potentially be cheaper and I wouldn't be vomiting on the boat constantly. And various other technologies. Yeah. And then I just want to say some acknowledgements. Tony, thank you so much. Jenna, thank you so much. And John Hughes Clark, if you're out there, wherever, thank you. To CCOM and JHC, thank you for the funding. This wouldn't be possible without the support of this center, and I very much appreciate it. Thomas Blanford, who's maybe out there, and Gabriel Venegas, they've been a huge part of helping along this process as well. So thank you to them. Brian Soares, John Long, Matt, and Daniel, as well as Franny, they did a ton of work with helping me mobilize, with helping do various things at the pier. So huge shout out to them. My mom and my dad, Ufuk and Jen, thank you for giving me life and allowing me to be here. I love you guys. And my sibling, Ipek, whatever you are. The CCOM community. This place has been incredible for me. I've grown a lot through this process, and so just my friends, my mentors, everyone here, I'm so grateful. Lots of gratitude. And just the greater Seacoast and our community, the nature, the water, the fish, all of them. Thanks, guys.
We have lots of time for questions, so hit it.
I may have missed it, but how did you account for the scattering in the water column compared to the bottom?
From the vessel-based measurements or the tripod-based measurements?
Both, because there was water between your transducer phase and your sediments. So I was just wondering, how did you account for the backscatter of the water?
Yeah, so I did the transmission loss correction to account for the predicted loss there. And then with the vessel, I would do a bottom detect, and I would window around that, and then I would apply my corrections to where that bottom detect was, those samples. And then for the tripod, similar, I would have a range defined for where I know the bottom is. Yeah.
I have a question about slide 14. I wrote down.
Slide
Maybe
14.
easier.
It's gonna be tough. I like it.
So you mentioned that those white sections is where you would remove those like turbid areas. I was wondering kind of how you quantified turbidity and kind of what your like range was that you said, okay, this counts, but this stuff is doing nothing.
Yeah, totally. Great question. So I used the phase difference from the split beam, and I took the 50 pings we transmitted, and then I would take the standard deviation of those 50 pings phase differences, and then based on the threshold I set, I believe it was 1 standard deviation, I would NAN the data that was not, that was above that threshold. Yeah.
That was my question. I guess I was was curious if it was like, if the signature showed up like on a specific part of the spectrum or something, or if it was, because I was wondering, why it was that you weren't able to, or if you could like still see the seafloor return and then filter out the noise, or if there's something about the way imagery was being caused that wasn't possible.
Yeah, so I suspect during those periods there was like that turbidity and potentially like bubbles and things. So the acoustic response of the seafloor was just completely masked during those periods, which made it impossible to, yeah. Thank you.
Great job.
So first of all, congratulations, I heard you passed. Excellent work. Quick clarification, I have a different question, but now that we're on the slide, remind me, what is the x-axis here?
So that's time for
Okay.
both.
Up top, the September 20th, the 70 kilohertz, is that, I guess I'm lost in how the top corresponds to, or how the title corresponds to the x-axis and how it ties into the wave height?
Yes, totally. So the title is just the start of the deployment
Okay,
for
great.
the tripod, and then that's the frequency and the wave type that I was transmitting.
If you have a plot like this for each day that it was deployed, have you considered kind of making like a animation or a video of the graph over time to see if you could identify like bottom features by how the intensity of return moves?
As like, if I'm understanding correctly, do you mean like it populating as an animation as you work across in time?
I actually think that's a bad idea, and I understand what you're doing now. Never mind. I'm gonna go back to my original question, 'cause that one I've thought through.
Okay.
So do you know if the area that you surveyed sees enough sediment transport that if we were to start bringing in sand to buff up Wallace Sands or Genes Beach, would the area that you surveyed see anthropogenic influence over time from sediment transport?
You know, that's a really good question. I don't know. We're at the mouth of the Piscataqua River, so there is sediment just coming and going through there. But I don't think I had enough year-to-year data to see if there was potential anthropogenic changes occurring, such as sediment being put in. I don't think it would be enough though, like the sand that they put at the beaches to get into our zone and affect the results. But I don't know is the short answer. Yes, Andy?
So, Kaan, you've got fair variability in the scattering strength here, in the same place over time. How does that range of scattering strength compare to the sort of model scattering strength of silt or silty sand and gravel? In other words, is this so much variability that you couldn't distinguish between those types of seafloor characteristics?
I think so, yes. The thing is, we can play with these parameters, the roughness parameters that I had mentioned, to kind of move these predictions up and down. And it's still reasonable, but there's a lot of overlap. It's not like we have unique solutions for the roughness parameters at a particular, within one sediment. So that makes it really, really hard to classify the sediment based on the variability we're
Go to
seeing.
your previous slide. I think that's a good, that addresses Andy's. So he's got three different things here, and it's almost the range that he sees in his data. So he goes from fine sand to coarse sand, and it all fits within the data he took.
Yeah.
It wasn't changing grain size.
And the roughness variability you're using, is that a standard assumption for the grain size, or did you?
They're reasonable assumptions based on some of the work that Dr. Daryl Jackson has produced, but they're working with a really limited data set. So yes, they're reasonable, but
But that's related to the grain size, not to the seafloor topography, the ripples?
Yes, so Dr. Daryl Jackson tries to basically link grain size with these roughness, the roughness parameters, and it's hard to say because they do link, but like also the way that there's a lot of overlap between the sediment types and the roughnesses that they predict. So it's like kind of wishful, but yeah, I would say it's hard to connect that grain size with the roughness. Glenna?
I was just curious, and this is a more biology-related question. So you touched on it a little about how the organisms on the ocean floor influence your data in one way or another, while also talking about weather seasonality. And I was wondering if you had any sort of biological seasonality that you considered or could influence your data. So any sort of migratory, mating, reproductive actions that might happen en masse to influence the seafloor?
I didn't consider it exhaustively. The extent that I looked at that was acknowledging that there is that cyclicity of reduced biology in the winter and more in the summertime.
Yeah.
But I think it would be really interesting to dive deeper into that question and see what comes of that.
Can I make a comment?
Yes.
That's the coolest question. It really is, because I think what he shows is that it probably is the biology, because yes, the storm events do something, but they don't cause it to go back up. That's biology. So you can probably tell the health of an area biologically by doing this.
Yeah.
By doing this. This has not been seen to this extent. No one has taken these types of measurements really. But I like the question. I think it should be done.
Because I don't know what that specific area might look like, but I was also thinking, like, for example, if you did it where horseshoe crab mating occurs, where there's these en masse movements of the organism which could be influencing the seafloor.
Or sand dollars, yeah.
Yeah, some type of seasonality of biological basis.
Yeah.
Mm-hmm.
Yeah.
Results.
It's pretty good.
Kim?
You talked about change over time. I'm kind of interested always in change over space. And so I'm thinking specifically that it seems to me you took an area that was fairly uniform, and I'm just wondering, you didn't measure this, but did you come across any literature that said, well, if you're next to where a big sand field is next to rocks or something like that, and the predominant current is this way, do you get comparable magnitude of change? I know it's not the subject of your thesis, but do you have any idea about that?
I am not sure. We did collect data on that vessel, and some of the edges of that area that we collected data in, like down here, because of the geometry of our setup on the vessel, we did end up insonifying some of the gravel region. So I think it'd be interesting to see what the variability in that like transition zone is like. But I didn't look extensive. I didn't look into that.
Okay, thank you.
Yeah, of course.
So you mentioned the biology and you showed some photos. Did you look at many photos? Was there a camera there you looked a lot at to see what are, and you showed the phosphorus, but was there other stuff going on that was like, oh wow, this is not what I expected as a engineer coming into this study site the first time?
Yeah. So our camera dies after the first 40 days, which is a super bummer, because we kind of miss like the most intense periods. That being said, yeah, we saw like sand dollars kind of cruising through and just destroying bed forms, which I think would definitely affect the acoustic response. And then there would be occasional things like just various other biology moving through and like seaweed and stuff tumbling on through. So I think like when those things set up within the acoustic footprint, yeah, it's gonna affect the acoustics, but we didn't get pictures for like the whole thing, so.
So it'd be hard to do a correlation with that.
Yeah.
Was that something you'd be interested in doing in the future? Is that a question of?
I think it would be really nice to have more pictures throughout the whole deployment. And I think Tony and Jenna, they've got like a revamped version of this whole thing that has the battery life for the full deployment, so that will be nice. And
Tony was a cheapskate, so he didn't spring for the expensive cameras, but Jen's got
We should be able to get 10 frames every 4 hours for 6 months. So hoping, yeah. But also point out, I think a lot of his pictures weren't good enough, right? Because it was the storms and stuff. So even out of the 40 pictures, I think you only get like 5 or 6 that actually look like something.
I think the river wraps around there a little bit, so the water's often just not clear.
So the next question is, would one of the other frequencies be better with that turbidity study headphones?
I think the 70 kilohertz was the best because it was the only split beam. And also, with regards to turbidity, I think it had the best chance of the acoustics, that energy reaching the seafloor. But that being said, yeah, I think it's limited to that because that was the split beam on board. Jake.
A bit of a simpler question. I wanted to make sure I understood the reason that you took data with both the tripod and the vessel. Was that to make sure that, like, I'm guessing vessels are a little bit easier to take data from. So were you hoping to find what you did of like the tripod data matching with the vessel data?
Yeah, it was to see if we could get like a little bit, like investigate the spatial variability a little bit more and see if there was that. It was pretty promising to see that the overlap was quite, it was lining up quite nicely with the tripod data. So that was that, but I also think there's future work which would look like looking into those other spatial regions along the track, because there's a lot of data there, and I'm just looking at this area that's closest to the tripod right now. So I think it would be really interesting to see, is there, and when we do that 90-degree turn, so like when our acoustics is hitting the seafloor at this angle, are we seeing a different return than when it's at this other angle? So I think there's like more there, a lot more.
This is a great data set.
Yeah.
You also have different span of grazing angles. Not looking at that overlap, but.
I think the sediments are coarser to the east, no? Slightly? It's all sand, but your furthest point east on your vessel track.
Yeah.
I think it's coarser material, so he's got variability on the softest stuff, the finest sand. So if you go to the coarser stuff, it might have a different variability. There's fun stuff to look at. So I guess you'll have to stay for a few more years. Can't wait.
I love you guys.
Not that much.
I'm curious about the design of your tripod. Were you involved in the setup from the very beginning, like from scratch?
Yeah, so the master's student, Tony's student before me, McAtour, he took on the original design of this, and they did a few deployments, and he actually has a paper, I think a 2020 paper, his thesis about that. And then I did a few redesigns to just like fix things that felt they would be a little bit nicer to handle.
Absolutely. What was the deciding factor for the height here?
Yeah, the limitation of the
good
Golf
question.
Challenger.
All right.
Yeah.
Is
It's
there
about the
an
max.
ideal height that you would have liked that something about near field, far field? What would your perfect lander look like?
Honestly, I think it'd be really nice if it was like, I mean, we're in 15 meters of water, but I think if it was like 5 or 7 meters, we'd just insonify a larger area, so we'd be able to eke out a little bit more information from that. That being said, that would have been quite a task to figure out like a pole that like, I don't know, whatever.
More questions?
So, if we're interested in the storms and figuring out what's going on then, how would you design it that was your target, rather than the in-between periods you get very low load your setup?
If I wanted to be collecting acoustic measurements during those stormy periods.
Yeah, do you think you could even get any acoustic measurements that give you any information that was worth reading?
I think we'd have to be closer. And I think that's the only thing that would help with, or like some, I don't know, some funky cone thing that like protects the insonified area, but then that would affect the mechanisms we're trying to research. So like, I don't think that would make much sense. So like closer, but then you get into that issue of being in the near field. So I think it would be tough to collect measurements during storm periods. I'll think about that.
Hindsight 2020, in the design of this tripod, is there any sensor that you would add for the next one?
Oh my god, yes. So they had this on the first one, Matt, I think. They had a photogrammetry set up to get seafloor roughness, which would be really nice for future students to have that information. There's potentially a way to eke it out with the multi-frequency, but that's even a bit wishy-washy. So I think having those surface roughness measurements would be primo.
Then are you limited again by turbidity?
Yeah, because it would be optical, so.
I know, right? More questions?
Past students.
Oh, God.
the different places in the sky, probably the nearest, but the size of the bed forms has been kind of amazing that like things are changing so much. Do you feel like you're picking up that scale, or are you still picking up more the smaller scale ripples that are, or were you picking up on the bigger things? And you think that you were able to detect that, or?
So the thing
What
with
is
the
that?
topography that I showed you guys is that this is, since it's the physical echo arrival angle in the along track, like in that X direction that I was showing you guys, we're just kind of getting the on-axis bathymetry. So like if I'm looking like this and there's a ripple that's posted up like this, we're not gonna be able to resolve that as effectively. So I think what happened here was that our ripples happened to form up just really nicely in that X direction. That being said, I think some other methods would have to be used if it was just going to be using the same tripod. Like another sensor would have to be on board to record. And I think optical measurements are good to provide at least the situational awareness. But using the sonar to eke that out, I think is difficult to get a more full picture with the current setup.
Any more questions? What's the scattering strength of a lobster?
Good question.
Well, thank you. Congratulations. Okay. I like this allowing 30 minutes for questions. It's been nice.
Yeah.
So hang about, chat with Kaan if you want. Should his mom bring him over here?
Great.
Good job.
Tape to kid. Tape to kid.
We did it! Oh my god.
Finishing is the thing of the ass.
We're just doing a hug line.
Yeah, we love you.
I also got some pictures of you.
Yeah, me too.
Thank
Yeah.
you.
You taking pictures of me taking pictures?
I do like doing that. How do I? What are you doing here on here?
September 3rd.
Oh, for that paper?
Sorry?
For that paper or?
I'm gonna be working on that in like October, November timeframe. I'm gonna just take time to keep that.
Hey.
Awesome.
Thank you. Thank you very much. Thank you for coming.
So this is
In a stage that you're gonna have to touch up, you're gonna have a series photogrammetry on top of all that. Good luck with that.
Yeah.
So there are two answers to your question. So it doesn't actually require the same kind of But, even with
Yes.
the
Yeah, I would love to. Things are changing. So let's go.
if they've done their job and their advisors done their
Hey,
job.
I want you to.
they advise
Thank you,
them not
brother.
to
Thank you.
get up
I appreciate it.
and defend something.
But I'll miss you.
I'll miss you too. Thanks for
This
being
is exactly the
I'm
same
not sure.
procedure.
Yeah, I'll just not. I'll see you soon.
Well, look, every 4 or 5 minutes. And that often turns out to be fun as well. Because we
And one like this, maybe, and one like this. Thank you.
Thank you. Can you send me those, please? Thank you very much.
She's all grown
Oh.
Yeah, this is good.
Yes, it is. Call me. Call me. That'll get through better. Because like I honestly don't check my phone very often. And so if you ring me, then I'm like, okay, I'm gonna ring them back.
He's trying to guess what the fine sand or
No, no, that's I prefer
that
that.
he can't, sometimes he can't nail it down to
Yes.
what was
Yes,
It
yes.
varies so much that it can be a
January.
fine sand.
Yes, yeah, of course. I'd love to meet up in the next couple of weeks.
So I think times
Traveling. I'll be sort of. I'll be going to Barcelona. And yeah, then I'm back here in October, and then I go to Turkey in November. Back here in December, and then in January I head to India. I haven't decided yet, but I think yeah, we'll talk. We'll talk. I haven't decided yet, but let's chat more about it, and I'll let you know. Because yeah, it would be lovely to meet up. Yeah, yeah, beautiful. No, different, kind of, similar. I'll tell you more. Yeah.
So they're changing. So it's not just pure playground sand.
Thank you. I'll see you soon. Like, seriously, the next few weeks.
It sounds like it's a, not uncommon.
Yeah, because the question over here.
Not at all. I've been busy. It hasn't been busy.
Having a situational camera that works for the whole time, so you can see the sand over.
Thank you for your pearls.
Summer seems to just acoustically, it seems to be, there's more runoff. So when Jen's looked at winter data, or
I'll see you soon.
winter.
Yes. Well, yeah.
Most of the winter, once the mechanisms.
Congratulations.
You did great. Destroyed.
How does it feel?
I feel
Imagine it'll take a year to be like.
yeah, I
So the scattering comes from
Moving to a new place.
things that are sort of wavelength size.
Dude, I was like,
We're talking
just
like
like this past week, into like feeling, this is honestly like, wow, like this flow is like beginning to subside. I think what's happening. So now I can think a little bit more about like that might be energy come back to yes. So that stuff gets more going on.
Yeah, perfect. I mean, I was in the
I know.
That's not everyone.
Keep your mouth up, you can go away.
Dude! Why haven't you got
That's why I drink
So we got kind of.
I feel honestly never might be
I was hoping she would dive off in on get some more.
I try.
Collect whatever.
You
Even
think
like
about
Jersey.
the ocean, like.
She's busy.
Yeah.
Yeah.
But he collected great data.
He's growing so much, and I think that's, I love seeing that as well. But he kind of did both. He's just like,
Hell yeah.
become a more.
He's got so much.
Just came to say.
Thank you for
He went out there every month.
Came to science. Yeah, I came, I saw, I
By himself.
Yeah, but I see so much growth in
Thank you so
him.
much.
I wanted to ask, I think you're gonna be super speaking, but tonight we are playing soccer. We're gonna do some.
I know.
Everybody's invited.
I know, well, that's sometimes key.
I think
For like, I know, we're such
Indoor,
indoors.
6 p.m.
Wearing steel-toed boots on, it's great working with him.
If you want
No,
to
you're
go
gonna get that, like,
Brazilian style, barefoot.
Go crazy.
Yeah,
We'll
yes.
have fire as a, like, a shin.
No.
Been working out for a long time and.
You have a professor here, so that's
Thank you very
okay.
much.
Yeah.
I really appreciate that.
So people can.
Yeah.
Exactly, yeah.
Thank you for the support along the way and lovely chats.
That's
Just
amazing.
I love it here.
marvelous community.
Unless I'm forced to leave.
My son forced to leave.
I heard Mr. John, I think I
Thank
was
you.
tired or something.
Thank you.
Kind of a soft pretend.
That is.
The image, that's
Yeah,
cool.
yes, a lot of
I
that.
saw
A lot of
what you
your
were
guys do.
doing. I think that's the hard time for me to answer.
I know what you're saying, there were so many that had, or, a lot
Still-
of these figures that had
still
like the dates set to the,
some
the
data.
wave height and then the.
Yeah.
Why are we doing it this way? It's like.
Okay.
Definitely. A lot of trial by error.
Yeah,
There's a lot of that.
No, there's
It's so cool to have like
Yes.
You could do that.
Universal experience.
Yes, yes. I think I'm learning that now. I'm like, okay, I'm not alone in this. This cauldron. It gets better.
It gets better.
Yes.
Somebody was saying like, keep it, but you can't, it was just.
I don't feel like honestly I've like learned so much like knowledge through this experience that like okay like there's like technical, but I do feel like there's like knowledge that I gained from this experience that's like this is part of like the growth process.
I mean, I have a CTE online.
She's super new, so.
There's space.
She won't be producing anything, she'll be taking courses.
Exactly. But it's really expensive on it.
Victoria, she's studying.
You haven't, tell me what to try.
Like senior blah 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 like executive like it's get really into executives like
And not only that, a quad pod, so kind of combine for.
like all the like
It's yeah, it's like
experiences translate into that and I was like he did what? You can do what?
yeah, right. It's so cool. It all
Went back into the space of like she had that like
beneficial to
other
circle in
Yes.
every direction.
Yes.
That couldn't hurt. It's just a matter of.
yeah, for sure, for
Yeah.
sure.
Each WBT is $1,000.
Yes.
And it controls.
I think for me, this period is
Yeah.
I had a person sit down there and take notes all the
Well,
time.
I love the idea of also something like, I'd love to take an hour here, just to, not even have just notes on that, like, video around, and see what the orientation of this one would be awesome.
leading into that.
Expensive part of USI. Or at least the most expensive part is being able to precisely locate reality. But if you could use, it would be.
so took her like analytical chemistry of geology stuff, like, you know, she like went out in the field.
If you could
And
use
she's
the
like interior design.
gigs
I've been interior design for several years. So, like, she's like, I've been like interior design, and she's like, but I've seen her do like top
Well,
stuff.
I mean, even if you just looked at the.
Yeah, like.
That's good, that's good.
She retained her knowledge.
I think that's absolutely something that could be worked out with, one of the labs here has a glue or not.
If ever you need to test it out.
Okay.
You go, you tell me, I'll
Yeah.
give you a location.
What's the
So I'm going to Star Island.
Okay, that's still not, okay. Yeah, I wanna say they've got congratulations to tether.
Thank you. I'm
We need to
gonna go
test
have
it,
a
or
look
we can
upstairs.
just go. Yeah.
This is the lab that I did, I worked in.
Oh, I'm really happy that.
Thank
She,
you.
CPAL doesn't have that bubble wrap everything. Yeah, although I think I remember hearing genders.
That's really sweet. I really appreciate it.
So I hope you go celebrate. There's a guy that came to try
Thank
to
you.
sell.
Thank you for the commodity.
Sent the
Thank
sales
you
guy
for
without an
just
engineering
like
background, and got one.
I think Val had all these questions
Yeah.
too, and I
What kind of flight controller do you have? And he was like, if you see here, it was attacked by a shark. And
Also,
so
yeah,
I
if there's a crash on if you're in an area, or we someday want to move somewhere, but, yeah, absolutely.
Thank you so much.
So
It's been a
congratulations.
pleasure. Yeah.
Okay.
It's great.
She has
Oh, I'm so glad you guys are wrapped up. I love getting to see what you've actually been doing. Because I've been like seeing little bits and pieces. It's really nice to see it all.
Thank you for being here. Thank you for managing the IT side of things. You kept my nightmares at bay. I had a nightmare the other night where there was like crazy IT issues with this. And I was like, oh my god. And then I woke up and I was like, Owen will be there. It's gonna be okay.
Yeah, you had no real questions from the audience, but you had several congratulations, great job from people in chat.
Thank you. Thank you.
Yeah, so they can take video over a long series.
Let's get together.
Not too close.
We're doing it for Mike.
Okay.
I had SARS.
Congratulations.
Thank you. Oh my god, it happened. Thank you very much.
You get 10%.
My dad's a
profits.
farmer.
With proof.
Thank you.
All right.
So, yeah, the answer's.
My students all give me 10%.
What, 10 for you and 10 for me?
And your dad gets 10% of any profits.
Yeah, yeah, I think that tracks.
Awesome.
How do you feel?
Good, good. I'm like,
You must have practiced.
Yeah, it's much better.
oh yeah, I got, yes, I am. Do you think I was gonna just, I mean, I guess, fair enough.
Much
Yeah,
smoother.
it's just a different kind of balance with it.
Yep.
Some of
Good
them
luck.
are good.
Petty vision.
Not now, because I'm questioning that very.
Yeah, kind of like fast forward.
Okay,
So
cool.
like, when explain everything
Yeah.
and like.
Do you guys have any things that you think?
That's probably really helpful and not.
Whatever you like.
Yeah, even in our department, like.
I would have asked you to do this. It doesn't matter.
Right.
People have an intuition for what it is. But say sort of what the definition of scatter is.
They're gonna be like, they're gonna need our mind.
You didn't think, so the quantity that's you didn't
No, that you throw up the DB slide and it's not obvious to some people. Wow, just what those.
Right now, like, I'm taking.
That's how for source stuff. It's all,
Did you?
that relates back to a linear equation. We're lazy, so we use DB.
As a whole.
That linear equation has hidden in it
Level, and he's like,
the
I just think
definition of
we're
scatter.
advantage for certain.
Mm.
But I'm
Time
like,
the intensity
I
at the
think I could do
signal.
that, but then I realized if it's
So the area's in there in that linear equation,
if it makes sense
the
for me.
range to C4 is in there, and then it's just a ratio of how much intensity is scattered back to you with what actually
There's no
exists
grading
at the signal.
component, there's no, like, it actually, as far as.
On Monday.
So it's like the best
You
thing
should
out there.
find
So
out
at least
if
if
he
you're
is.
graduate student that doesn't have your own research yet.
Well, I think also when you talk about slide, I realized it makes it seem like that's, you only did it for the tripod, but that's the same thing as doing the best. So I can think
What was
it.
the first effect?
I feel like it's all the thing did that with the tripod.
So I
I realized with that schematic, so I'm like, oh, maybe you need a schematic
started
design
yesterday
of
with
shit.
the
point, the ship
like 2 days.
has different angles, I don't know.
He's like, oh, okay, meant to
But
tell you.
but if you present in Hawaii, you don't
Yeah,
have to
you don't
explain what
know.
DVR, because they're acoustics.
In Hawaii.
You probably don't have to explain, you don't have to explain scattered
super worried about it.
You can remove like half the slides for Hawaii too. It's like-
That's it.
Yeah, I
I'm
think
taking
I
it
like
because
base
I
questions,
truly
and I
need
think
Tom Blanchard
we
for
could,
class.
I could make that clear at the beginning, like why you use two platforms. So you get one of them, you get the temporal.
That's how I
you get
get
the
It's a
spatial.
time temporal
Yeah, and you get different grazing angles. So let's see if they're different and kind of present that in the Is it different? Oh no,
There's some pretty firm things that came out.
Actually, is an acoustic measurements class.
The spread in the ship was the same as the spread in the.
What you say?
So you can't say, oh, so there is,
In the ocean instrumentation program.
that's a biggie. The 10 dB thing's a biggie.
And for the OE masters is
Yeah.
good, but I've already met this requirement.
Looking good.
Thank you guys. Thank you so much.
You sign up for research.
I have something for
and
you
you sign up for
in
lessons credits.
the car, so I'm gonna grab.
You don't realize.
But maybe
That's
I'll.
an option, that's right.
It's not right.
So.
Oh, actually, it is Raka.
Raka.
Yeah, it's Raka.
Is that what we call it?
Yes, Raka.
Wait, is that an alcohol?
In Greece, they call it Raka.
It was an Armenian sisters were at like.
It's-
Lusa.
Yeah, not that
Oh,
far.
this was different. This was kind of anise.
Yeah. So is Raka.
Raka. I think, well, I've heard two different things in Greece, but the one I'm talking about is grappa. But in Greece, they have a
That's
different.
where all their friends were, like, so they went to that church, but you know, like.
I've had expensive
Same religion,
grappas
just
in Italy. And I've had homemade grappas in Greece, and the Greece stuff's always better. I have no idea why. Just taste it.
They know. The Mediterranean, like that, like eastern side of the Mediterranean.
Well, yeah, it's a different grade, probably. It's a drier climate, probably. Well, definitely. I didn't tell you my grappa story, or my grappa story. Did I tell you? So the conference, this Greek conference, it was in the first 2 years it was in Heraklion, Crete.
Cool.
So we had, it was a Wednesday, and
That's where we met.
this was 2005. You were in the cradle or something. Still in your mama's belly. I don't know. No. It was 2007, I think this one was. It was the first two times they did it.
You have to go to that.
So my first student, Tom Weber, was presenting his
Because you can find it everywhere.
his PhD stuff. He was done. He wrapped it up in 2006. So it must have been 2005. So it like we're gonna skip Wednesday afternoon. We're gonna go boogie board.
Heck yeah.
So I said, heck yeah.
Hi, as long as-
So I have a bad habit of forgetting.
Other cakes are kind of.
I'll go to cold
they make them
climates and
more
forget to actually
commercialized
pack a
and
sweater or jacket, so I
Like-
buy it. When I go to warm climates, I always forget a bathing suit. So I'm like,
I'm in Dover now,
so
so.
you guys start, I'm gonna go across the street to one of these Greek shops, wide
They
open.
only have like the Speedo kind.
They did not, but it was the cheapest stuff ever. Like they got it, for a nickel a piece, and it was really
A
crap.
sheet of plastic.
It was cheap, but I went in. I was gonna use it one afternoon, and
Yeah.
so I go in. And I don't speak Greek, and the old man doesn't speak English. And so I finally said, I need a
This could be one of my signatures.
speeding.
Yeah.
And she goes, and he goes,
Very good for
and he goes, what size in Greek?
You like my
I'm just
red?
guessing what he's, and I go, I don't know. So he just gets
Still
something,
in
holds it up to me,
Yeah.
and it looks like the 70s. It's got the white piping.
Yes, yes.
So he gives it to me, and I go, how much? And he goes, 15 euro. And then I said, okay. And his face just fell. Like,
Oh, he wanted to haggle.
he's like, I'm ripping this guy off. And I'm like,
And for you.
whatever, yeah. And so he goes, all right. So he took my money. Then he goes,
Oceanography, yeah.
somehow, he had enough English to, do you like rock or whatever the graph means?
Different names for the same.
And I said,
Looking for jobs.
sure.
Graduating with my
I
PhD.
didn't know what it was. So I go back,
Oh.
he opens the curtain, we go back.
So sketchy.
No, he's a nice guy.
Geology.
So I go back and it's
They were all doing like.
This is normal.
office.
Okay, this is normal. Okay.
He pulls out a plastic water bottle. It looks like it's full of
That's
water.
normal?
Yes.
It looks like it's full of water. And he proceeds to pour me, it wasn't a shot glass, it was a little drinking glass, but it was,
Yes.
he fills it up, right?
Uh-huh.
You know what I'm talking about?
Yeah, I do.
So I drank it and I went, wow, that's pretty good.
Did you dilute it?
This was not, it's not ouzo.
Okay.
This is grappa, man. This is like.
So you drink it straight
You
up?
drink it straight up.
Okay.
So he had a glass, I had a glass. So then he pours another one. So it's equivalent. I think I had 2, I don't remember.
That's-
It's the equivalent of like 5 or 6 shots.
Yes, it's a lot of alcohol.
So then he's all happy. He goes up. He shows me. He has Polaroids of his vineyard. He goes, my grappa came from these grapes. This is mine. I made it.
That's amazing.
It was fantastic.
Yeah.
And so I went boogie boarding, kind of drunk.
Yes, yes, yes.